Hi, I'm Brian Carrier with Basis Technology and Cyber Triage. This video is a demo of our Cyber Triage digital forensics and incident response tool. I'm going to cover the basic use of the software so that you can get an idea of what it can do and how to use it during evaluation. If you have any questions, please send a message to support@cybertriage.com. Visit cybertriage.com to download your free evaluation copy of the software. This is the opening screen for Cyber Triage. Every host that we're going to add will be added to an incident. So we'll start off by pressing New Incident and giving it a name. This will now make a database for that incident and we'll add a host to it. So there's 5 ways to get data into Cyber Triage. The first 3 are all going to collect data from a live running system using our collection tool. Now we have a single Windows executable collection tool that will grab various artifacts and files of interest from the live running system. This will not be a full image. It's just going to be the relevant things that we want to bring over from the system that you can configure. The difference with all 3 of these is how that collection tool gets onto that live running system and how data will get sent back into Cyber Triage. We'll dive into a couple of these in a second, but while we're here, we can also bring in a disk image. Our collection tool is based off of the SleuthKit, which is an open source software that I've been involved with for over 20 years. And we use that on a live system to access locked files and bypass rootkits. And therefore, to us, a disk image is very similar to a live system. So we can analyze an E01 or a raw image. The big difference is you're not going to get volatile data from that disk image, like processes, open network ports, etc. Lastly, you can bring in a memory image. We do not have memory capture capabilities, but if you have a memory image, you can bring that in and we will run volatility version 2 on that and run a bunch of modules to simulate what our collection tool does. The results are not the exact same thing, so the UI is not the exact same thing you'd get from using our collection tool, but it's basically a UI around running a bunch of volatility modules. So let's dive into the 2 most common methods of getting data into Cyber Triage. So we'll first do Live Automatic. So Live Automatic is all about using PSExec to copy the collection tool from this computer to the live running computer. Now, there's nothing really special about PSExec. We just ship with it because it works in a lot of environments. So it's the easiest thing for us to ship out of the box with, or support for it. You have to install it yourself, but it's the most universally acceptable thing in many environments. Now, if you're in an environment that does not allow PSExec, you can also use whatever IT infrastructure and EDR or something else to deploy our tool. You can reach out to us for help on that. But basically, we just have to get our single executable on that system and running, and we ship out of the box with a way of doing it easily with PSExec. So to do that, press Live Automatic, enter in the host name that we're going to copy it to, enter in the domain, the username, and the password. Next step is configure what you want to collect off that system. So by default, we're going to grab all of these things. We're going to grab things around users, such as what accounts exist, when do they log in, and what do they do? What network shares do they access? What programs do they run? Websites they visited? We'll also collect things around malware, persistence mechanisms, what was running, network connections, caches, and then OS configuration. What auditing was enabled, was the firewall enabled, remote desktop enabled, etc. These are all very fast, right? We can get these from the registry, event logs, prefetch, etc. They're very targeted. We will also, though, do a full file system scan if this is checked off, which means after we do the targeted collections, we'll go through and look at every file in the system to look for other suspicious things that we didn't find a reference to in the registry. Now, that's going to be the slowest part of the process. So if you want, you can choose skip file scan and it will uncheck that. Or you can do custom scan and say, hey, I just want to grab processes and startup items, and you can pick and choose what you collect. For those of you who have taken our divide and conquer DFIR process, you will recognize these groupings around users and malware and OS configuration. Next step is after we've configured what host to collect from and what we want to collect, the next setting is to configure what you want to do with those files that are coming back in. So we're going to collect a whole bunch of files from startup items, triggered tasks, processes, what programs were run, etc. As part of your Cyber Triage license, you get access to our online file reputation service. This is an API backed by Reversing Labs, and it gives you a broad coverage of malware scanning engines, 40 plus engines. So it's a lot like VirusTotal, in that it gives you a broad coverage of opinions on if a file is good or bad or suspicious. So this panel is going to ask you how you want to use that service. So by default, we're going to query that service using MD5 to see if someone has already uploaded that file and analyzed it. And if so, you'll get the results back. This next set of options are what do you want to do if that MD5 does not exist on the server and that no one's analyzed it. Are you willing to upload it so it can be analyzed by the 40 plus engines? Or if not, you just want to mark it as suspicious so that you are aware this file has not been seen by someone else or uploaded by someone else in the past. Now, two things to note that come up a lot on this topic. One, Reversing Labs is a bit different than VirusTotal in that the goal here is not to kind of like spread the files out for sharing and collaboration. If you upload a file, it's the results of it. The results of the analysis will only be available to your fellow Cyber Triage customers if they query for that same MD5 hash value, and they'll just see the results. It's not tied to you, and they're not going to get the content. Second thing is we're only going to upload executables, DLLs, EXEs, etc. We're not going to upload Word docs or PDF files, so there's a very low risk of revealing PII as part of that. So if we start here, this would copy that collection tool over to that host with psexec, collect what we've configured, and as data came in over the network, this kind of analysis would begin, and a bunch of other analysis. But I put in bogus data, so this is going to go nowhere. So I'm going to back up here and show you the second way of getting data in that's most popular. So this is live file. Live file is all about it's up to you to run the collection tool and you to import the data back into this. No network is involved. Well, sometimes not always involved. This is most used in situations where A, the computer has been unplugged from the network, and of course then we can't do stuff over the network. Or B, which is honestly the more common one, is you're a consultant or an MSSP and you want to send the collection tool to your client for them to run it because you don't have VPN access. So you'll email them the collection tool, they'll run it, and then they'll get the results, and they'll get the results back to you, and you can import them. Or it's also used in companies where they have a slow network connection, perhaps to a remote office. They may use this approach as well and have a local IT person do the collection and then send results back. So key point number one, it's up to you to get that collection tool on the system. So you have to know where to find it. Well, you find that down here with collection tool. This will prompt you where to save things to. You can pick a drive letter here. It could be the USB drive. It could be a network share. We don't really care. If you're going to do S3, you can check this checkbox here. Now, what this means is that once the collection is done, the collection tool will automatically copy it to a pre-configured S3 bucket. So if you're using Amazon, you can plug in the details here. If you're using some other S3 provider, you can plug in the details here. Essentially, these all get saved to that collection tool for that user to run. There's a variety of settings here for session tokens, and you can do various permissions to only have write access but not read access, temporary tokens. There's a variety of ways to secure those keys that you share with that. Now, once you extract the collection tool, you'll get a folder such as this. The Cyber Triage CLI is the collection tool that knows how to parse the registry and event logs and prefetch and all those kind of things and collect file content. You can open a command prompt. You can run this. There's a bunch of arguments you can give it. If you love command prompts, that's the way to go. If you're going to deploy it over your EDR or some other tool, this is the program you want to send around. But if you're going to send this to a customer or a client, you can send this entire folder. But you can tell them to launch this program, Cyber Triage GUI. And what this is a thin kind of UI wrapper around the command line tool. It's very simple looking. It's very kind of 90s looking, honestly, but it's got no DLL dependencies, no .NET requirements, nothing. It's a very thin, easy UI you can ship around. And this is where they can configure if they want to collect, where they want to send it to. Do you want to save it locally? Do you want to upload to an S3 bucket if it's configured? Send it to a server, apply some password encryption, etc. So this is basically a thin, easy way for someone else to run the collection tool without having to worry about command prompts. If I hit start here, it's going to start running things and saving things out to that folder. As you can now see here, there's 2 new folders. So that's the basic idea of that. And then once you do the collection, then you can then bring stuff back in with live file. So you can go to live file, and we'll do this as part of our example here. We have the host name. We browse to one of the JSONs that was brought in from the USB drive or S3 drive or some other kind of file share. We then have to, as well, again, configure what we're going to do with the data as it comes in. We'll choose the default settings here, and we will hit start. And now all of that data is being analyzed. So that little section was all about the ways of getting data into Cyber Triage, right? And we try and make it as easy as possible. We probably spent 5-10 minutes on that, covering the basics. But in practice, what happens is you get used to this and you just kind of put in some host names, hit go, and data starts coming in very quickly. So what's going on now is all of those thousands of artifacts from that collection are coming into Cyber Triage. They're getting saved to the database and they're getting analyzed. One of the big things about Cyber Triage is the scoring, to make it easier for you to figure out which handful of those thousands of artifacts are actually relevant to your investigation. So you can see here we have 3 bad and 12 suspicious at this point. These will go up and down here as more and different results come in. Let's do a basic UI tour here though. Left-hand side are all the data types. You'll see here there's the same structure that we saw as part of the collection around users and malware and OS configuration. Let's click on the bad items. We can see here there's 3 bad items at this point. One is a file. It's some malware. We can click on down here and see more details. So we can see here that there's some malware. 38 out of 45 engines thought it was malicious. We can click on it and we can see it's Mimikatz. We can see when Reversing Labs first saw it, etc. So the file tab here is going to give us all the information about a file that was selected above. So we can see here all of the 8 NTFS timestamps, hash values, etc. Now you may say, of course it's going to. We chose a file. Of course we'll get file things. But it's kind of cool here. We've got a process tree, for example. We can click on one of these random process trees and we can go to the file tab and we can see the details about, in this case, the executable runtime broker.exe, about its status and its malware scan results, etc. So if anything that we've chosen on top has a file associated with it, we'll show that to you on the bottom. So let's use the back arrow here and we'll back up to where we were before with this file. And we'll kind of continue our little quick UI tour here. The process tab over here shows us if that selected item has a corresponding process. It doesn't. Mimikatz was not running at the time of collection. History is going to show us when it was run, if it was run. So in this case, we know it was. And we have that from a prefetch file. Now you'll say, I already knew that. We already had that appear that it was run. And that's true. And that's because we do propagate some of these scores. So once that file is found to be malware, we will propagate it out to say, hey, this is also when it was run. But in this case, even if we hadn't done that, this bottom area allows you to kind of get that context on when something was run or not. Startup items allows us to see whether or not this item was a startup item and was going to be run automatically every time based on some trigger. In this case, it wasn't, which Mimikatz isn't really a tool that would do that, but this is where you would find that. Other occurrences does correlation with past cases. Analysis results gives you information, more of debugging information on how we analyzed it, etc. Lastly, upper right-hand corner is a timeline of all of the times that we know about so far for the bad things. So we have 3 bad things at this point. We have 4 timestamps. This is your constant reference for what things are known so far about the incident. The other bad item here, which we don't really have time to dive into very much, but you may know about, is the accessibility feature backdoor. This is the hotkeys backdoor, where someone can, use for remote desktop to make a command prompt to show up to give them some backdoor access. And that was detected as well based on some registry settings. So without much work, right? We entered some information, collection happened. We watched a bunch of progress bars go back and forth and scores go up and down. We've got 3 bad and 12 suspicious things without much work. Now, this may be enough for some investigations of game over, right? We know enough about this host. Let's move on to something else. But for the sake of a demo, let's see some other things that we can do to better understand, what's going on this system. So there's no single way to do an investigation. Everyone has their own kind of path. Hopefully they all get to the same endpoint. But one thing I like to do is say, hey, we know we have some bad stuff here. Let's keep on digging and pulling on threads on these bad things. So let's say, hey, we have this Mimikatz. Let's better understand maybe what else is in the same folder as it, right? On the theory that where there's one thing, there's other bad things. So you can right click and you can say view file and directory, and that'll bring you to the app data local temp Java folder. And we can poke around here and see what else is in there. We can see some zip files in here that got flagged because they are password protected. We see a Java update.exe file on here. In a real investigation, we spent some more time poking around here. Now, to be clear, a bunch of these files we're not going to have content for because we didn't collect all file content, right? We did a very targeted collection off that system, and the collection tool decided what to grab content for. So for some of these files, when you navigate through the file system tree, you'll see names, you'll see times, but not content. If we had done this as a live collection, you could go back and choose the menu button here, a button here to go back and grab that file. But because we imported this from a JSON, Triage has no clue how to go back to that original location anymore. And so right now that option is not available. So we can poke around here. We can go up some folders, down some folders, etc., and better understand what's in the vicinity of that of our Mimikatz file. But we can back up now, and the other thing we can do is right-click on this and say View in Timeline. And this allows us to see what happened before and after our Mimikatz was created on the system. So afterwards, we can see things like ipconfig and netstat was run. That may be interesting. We can see Java updater was run before that. It's also Java, also in that local temp, a triggered task, some cookies. Again, in a real investigation, we dive into these things and better understand them. I'm trying to give you a kind of a high-level demo for this, so we're going to breeze by some of these details. This data is available for you in Triage, so you'll be able to play with this data and better understand it as you're going along during your evaluation. We can see PowerShell was run, Word was run, as a payroll-issues.doc file, a file download, a user login. As you're scrolling through these things, some things may, kind of be suspicious, right? Of like, hey, why is PowerShell running right after Word? And why is there a Word doc that's kind of was downloaded right before all this stuff? A bunch of things may be suspicious to you. Some people want to dive deep as soon as they find them and understand things. Other folks want to just kind of flag it and follow up with it. Whichever you want, it's fine. If you just want to say, hey, I want to follow up with payroll-issues.doc later on, then what you can do is you can mark it as suspicious. So before we saw that modules were scoring things, but you can also score them. So you can also flag that as suspicious. And then what comes up is our recommendation engine. So Triage has a recommendation engine that is going to basically say, hey, if you thought that was suspicious or bad, you may also be interested in A, B, and C. So in this case, it was saying, hey, if you care about that payroll-issues.doc file, perhaps you care about the web artifact that downloaded it, because you may want to follow up with where it came from. So in this case, you can say, yeah, that's a good point. I do. And you can mark that as suspicious. And now we have two more suspicious things in our list. We went from 12 to 14. The web artifact, and as you can see, that's yellow, and the Office document itself. You can also say, you know what? Maybe you're going to open this up. You're going to see some macros, some funny things. You can say, this is bad. This is part of the incident. And again, this is where now you'll be prompted to mark this as bad. And it will ask you if you want to mark the download and the user count as bad. Maybe you're not quite ready to yet. You'll keep them as suspicious. You can hit apply here. But we can now see that payroll-issues.doc has got a little red icon, and we can now see it in our timeline of this doc file came in, and then other changes happened. So once we've kind of dove into all these things and we've understood kind of the context around our bad things, then we should review our suspicious things. This area up here gives you kind of a listing of all the suspicious ones in kind of a generic format, right? It's kind of one column with kind of a name, a type, and a description. And you can go through all these things and understand why they've been marked as suspicious. These same 13 that were also available in these more specialized views, if you'd rather go that way. So the accounts area is going to show you all of the accounts that existed on the system that were used. Who had logins, who didn't log in, who had accounts who never logged in, etc. You can see if there were admin, date ranges of activity. You can see here that JDO got flagged because they have outgoing RDP connections to 7 different computers. Now, Triage doesn't know who JDO is. They don't know if JDO is an IT person who does a lot with remote desktop to different servers, or if JDO is more of a admin assistant who never uses remote desktop as part of their job function. So Triage will mark it as suspicious, and then it's up to you to know, based on what your knowledge of that job role is, to figure out, is this part of their activity or is their account been taken over by a malicious person? So if you want to know what those 7 hosts were that they went to, you can go to the user tab and you go down here to outbound remote login events, and it will show you what those remote logins were. Also, the inbounds are shown, local are shown. These 3 tabs are basically merging in several event logs into kind of a one unified view of kind of inbound and outbound remote logins. You can decide, is JDO good? This is part of their job. Then you can mark them as good, and their little yellow icon goes away and they turn green. Same with logins. These will show different logins. Some are getting flagged here because they changed accounts. Locally, they were JDO. Remotely, they're administrator. Again, maybe JDO is an administrator and this is part of their job, or this is kind of some account takeover or lateral movement going on. One thing to note before we kind of wrap this up is program run is an area that has often a bunch of false positives when people run this evaluation on their software, on their own systems. The reason is because that we're going to flag things that ran out of, non-typical locations, things like app data and program data, which are supposed to have just data based on their name, right? But there's a bunch of legit programs that do run out of those places. I'm sure you've all come across, right? Like a bunch of the web chat, conferencing software runs out of there. Google Update will run out of there sometimes. So what happens is we'll flag those as being suspicious. The malware scanning will often come in and squash that down, saying, you know what, these are fine, these are good, don't worry about them. But we only have a certain amount of trust with the malware scanning on new files that have only been out for a couple of weeks or so, in that we want to give the malware scanning engine some time to catch up if there's actually malicious stuff going on with them. So what you may see is if you have a version of Google Update or some other piece of software running out of app data from last week, that probably will get flagged as still being suspicious on there because the malware scanning didn't squash it. If that's annoying for you, you can right click on it. You can say not a threat, and you can add it to either an incident level good list, meaning just this one incident, or global, meaning future incidents as well will also basically ignore this folder or this executable. You'll notice over here too, there's a column over here that is seen before. This is basically showing you how often you've seen a given executable or file before in the past. At the incident level, meaning within this incident you've created, how common is it? Now in this case, we only added one host to it, so there's nothing else in the system. Global is basically for all your past incidents. How many times have you seen it before? And this last number is how often they've been flagged. So this system here gets used a lot for demos and a lot of the same data over and over again. So these numbers are kind of consistent, but on a more real normal system, you would see far more often diverse numbers here on no one's ever seen this before, or this is really common. It's all over the place. So as part of investigation, you can go through all these things and navigate through the startup items and processes and active network connections and listening ports, etc., and squash all these suspicious numbers down to zero and decide they're good or bad, and better dive into some other areas just to understand what's going on in the system. So lastly, after we've gone through and marked all of our suspicious items as being good or bad, we can go over and make a report. So you can see here the report option gives us a choice of HTML or JSON. We'll make a basic HTML report here. Very basic high-level report here, giving a table with a summary of the items that were marked as bad. You can click on these to the View Details button, and it'll bring down in the middle with all the details about timestamps and MD5 hash values and malware scanning, etc. There's a similar section for all the suspicious things. Again, there's a bunch here because we didn't go through all these and mark them as good or bad. And then finally, in the bottom is a timeline with the same as the upper right-hand corner with the times for the items that were marked as bad in the incident. Well, that's it for the demo. I hope you saw the power of cyber triage and how it can make your faster by making it easy to collect data with a few button clicks, how the scoring can make it easier to focus on a small subset of artifacts, and how the recommendation engine can help you follow up on other clues. You can visit cybertriage.com for a free 7-day evaluation where you can use the same data you saw here in the demo. If you have any questions, please send a message to either support or sales at cybertriage.com. Thanks.